Hey, you're Steve Morris Engines. Today we are going to be dynoing this Studebaker Avante. PROMOD Studebaker Avante. Go check out what it looks like. He doesn't have the doors or front clip here for it, so it's really a 100% different looking car. I mean, it's pretty cool. He just wanted to be something totally different. Flat out, regular, dual rail, ProMod style car. Not with a full-blown ProMod engine, but pretty darn close. So now this is one of our 540s. All right, now this particular engine is obviously, you can see it's got our billet intake manifold, but this has a 14.5 degree cylinder head, so like a Big Chief style cylinder head, not a conventional big block Chevrolet head, but it is a conventional big block Chevrolet block. So this has got a cast iron dart block and 14.5 degree heads. Runs dual fuel. So on this particular model here, we have two sets of 220s. Now, a little bit of tech on that. So we run these injectors at a higher fuel pressure. So as you increase fuel pressure, increases the fuel flow, makes the injector bigger. Pretty common sense, right? So we have already run this on gasoline for the street drive. So I didn't want to bore you with that, because all we do is work on idle and get it to idle really nice, and then drive at part throttle. So and then check the cooling system. It's definitely a little undercooled right now. But I think he might end up doing something a little bit different with that. But it surprisingly works a little bit better than I thought, to tell you the truth. With that much radiator, it works a little better than I thought. But I think it was just gradually creeping up. So we're just sitting here running it on the hub dyno just at 60 mile an hour, just putting a load on it and just hovering there. So now what we're going to be doing is we're going to put this in what would be our race mode. And so we go in, we're just going to check the valve lash, reset the valve lash, and run a methanol tune in it. And what I'll do is I'll show you some stuff on that on the computer next. All right, now I wanted to show you something else here, just on tune. So we have converted this from, we just put the, this we're not running like we did Cletus's car, where it's, because it doesn't have two fuel systems, so it has one fuel system. So we actually drained the fuel and put methanol in it, and then set up for the methanol tune. So I've already done the methanol tune on the dyno, engine dyno. And so now we're doing it here. Just show you a couple quick things, couple little quick references, so you understand what's going on, and you can look at something and you can see if it's wrong really quickly. All right, so disregard the numbers. I already talked about that. Numbers don't mean anything. It's just a reference. We want to know what this number does for us. This engine likes this number. That's fine. Just use that number. We want to do what it likes. Okay, but one thing here is the way the fuel graph looks. It is a huge pet peeve of mine, and I always will do this and come back and look at people's stuff. Now this is what the pound per hour fuel graph looks like. The more RPM, the more boost, the more fuel. Makes sense, okay? Now if you can do the conversion on this, this is the VE table, okay? Now the VE table is different because it's most efficient at peak torque, less efficient as it goes over peak torque, especially turbo cars, because it's a reference between back pressure and manifold pressure of what a VE number actually is. Very, very, very short explanation of it. There's a lot more to it. But one thing that is my pet peeve is your 3D table needs to be smooth. It needs to look like this. If somebody has some kind of table where they have done tuning on it, and they only tune and they only change the numbers in certain areas, and your tune-up, when you look at it in a 3D table, looks like the Rocky Mountains right there. Let me expand in on that. So see if you have these area where you just tune, where it just runs and you don't tune anywhere else, that's just wrong. That's the wrong way of doing it. All right. And now what's interesting is if you don't do it and look at it in this VE 3D table, let's convert back to the there. You see it's not much, it's very not pronounced, but it's still there. And you can see what it looks like in a smaller numbers on the VE table. Right there, it's much bigger, more pronounced. You go, oh wow, there's a problem right here. Oh, there's a hole in the fuel map. There's one cell, and if the engine crosses across that one cell, it's going to go rich for a minute or go dead lean for a minute. So we always want to have your stuff smoothed out, tuned all the way around it. So if the engine ever runs in a different area, it's still safe and still correct. So I'll come in here and fix this stuff like so, to make that all smooth back out, so it doesn't have any little holes that it hits in the fuel table, so it doesn't have any spikes or any other little issues. Oops. Now this is on, and now I only do tuning on Fuel Tech and Holley stuff. I can tune everybody else's stuff. It's really not a problem, but it's always a matter of everything is so darn different. Everybody's got different terminology, keystrokes. Air is air, fuel is fuel, spark is spark. That's not the problem. It's usually just getting around the program that's always the issue. But long story short, make sure that your fuel tables are nice, they're smooth, they're tuned all the way across. If you open up that fuel table and go to your graph, so this is one thing you're looking here, really hard to see any spikes or any problems here. It's a little bit easier when you convert it over to the fuel volumetric efficiency, which you see here's the most amount of fuel, which is close to our peak torque area, and then it tapers off. And then when we graph it, that looks nice, looks correct. We do the conversion, that looks correct. Least amount of fuel, least efficient down here at idle, most efficient at peak torque, tapers off after after it crosses peak torque area. So anyways, just thought I'd tell you that. We have everything all set up. I'll show you a couple of other things as we get along to tuning this. Okay, so I'm going to actually show you guys, I do have a video in my Steve Tech videos about how to lash valves, but I'm going to go over this thing with you real quick right now. There is one proper way to adjust valves. I don't really care what anybody else says. There is one proper way of really adjusting valves. There are other ways that aren't as good but can work. That's fine, but this is the proper way of adjusting valves. All right, so what you're wanting to do here is, I'll show you on this intake and this intake and then this exhaust right here, is we're going to adjust the exhaust rocker. The exhaust rocker is opened all the way. It's now closing. Okay, now this intake rocker is already opened all the way. You already saw it go through the motion, and now it's almost all the way closed. In fact, I'll roll it over one more time so you can see it here. Right there. So it's about a 1/4 inch away from being closed, somewhere right in that range. What you're doing is you're ensuring that this rocker arm right here, the one we're adjusting, is on the base circle. That makes sure that it is positively no little bit overlap. It's on the base circle for sure. Now, what we're also doing is, on my iron block stuff, I also like to adjust these things always cold. All right, so we adjust things cold because it's way more consistent, and all of my camshaft designs do not beat up valve train very hard. So They're not very aggressive. I also have a video on that on the Steve Tech on camshaft design and what we're talking about with an asymmetrical lobe versus a symmetrical lobe. Slower closing ramps versus faster closing ramps. So all that stuff just makes things easier on parts. So an iron block with aluminum head grows about usually about 5 to 6 thousandths from cold to operating temperature of like 125 to 150. Full aluminum blocks will end up growing in the range of about 20 thousandths. So I set those up really tight. So aluminum block, aluminum head motor, will very typically I lash them up at 10 thousandths cold because they end up being about 28 to 30 thousandths hot. And then, but like I said on this, we're going to adjust this at 22. Now, the other thing I like to do is I always do these things at the same intake and exhaust. The couple thousandths is so minuscule in performance, it's actually negligible if any. But I like to keep things simple for people. So as I'm actually talking about this for you guys, I'm actually talking to Dave Burns that owns this engine, so I'm showing him how to lash valves all at the same time. So anyways, the intake is closing to adjust the exhaust. It's exactly backwards to adjust the intake. So on the intake, now it's closed. Both are closed. This is where some guys want to try lashing valves, but it's too hard to do this and be consistent. So now this exhaust valve is just starting to open, about a 1/4 inch open, and now we adjust the intake rocker. All right. So, and I like to adjust it at the same amount to make everything the same and universal to keep things easy for you guys. All right, so that is the proper way of adjusting rocker arms. All right, what I also want to go over here with you is, so show you how to adjust the valves, right? Now, if once the valves are set, once it's been running, it's pretty rare that anything changes 1 or 2 thousandths, maybe 3 thousandths. If you feel like changing it, if you feel like adjusting it, it makes you happy, gives you, you're bored, you want to do it, I don't care. Doesn't matter what it is. But the biggest thing is if this thing has been all fine and then all of a sudden it is 10 thousandths bigger or 20 thousandths bigger, do not adjust it. Figure out what's broke. I promise you, it doesn't just change. Something is broke, something is going away. So, golden rule. Once valves are adjusted, don't adjust. Once the valves are adjusted, don't, let's see, the proper terminology. Yeah, don't make a bigger deal out of it. It's going to be 1 or 2 thousandths. If it's anything more, look for what's broke. Look if the lifter's going away, the push rod is wearing out, getting short. If you're lucky, then maybe, you know, a nut came loose or something like that. But very rare that something just all of a sudden moves 10 thousandths or more and is not broke. If you're in a pinch and you had to adjust it and then come back and check it again, and if it gets bigger again or gets smaller again, just stop. Something's wrong, something's broke, it's going to be bad. So if things get loose, usually it's wearing out and the lifter has a problem. If it's getting tighter than what it was before, then you typically have a valve problem where the valve is actually getting longer. Big deal. Definitely stop there. You keep adjusting that thing and the valve is starting to stretch, the valve pops off and you're going to be broke. So very bad thing. So always just do the very minimal. Once the stuff is set, it's very minimal. All you're doing is checking stuff to make sure it's not broke. All right, so what we've done here is we've already gone through the basics. Now this is a brand new combination in the car. I've already dynoed it, I've already tuned it. None of that matters. We need to verify that it's correct in the car. So whether you're doing this at the track or on a hub dyno, or even if you take it off the hub dyno and go to the track, it does not matter. When this thing, every new combination that it is, every time it goes, you know, from, if it's not gone down the track for the last 50 times perfectly well, you need to always do this. You just need to do some short pulls on it first. So we've already set the timing, we've already verified it. I've already got it starting, idling, running on the methanol, revs up, does everything fine. So the first thing you do is a short pull on the dyno. If your guy wants you to just, it's a brand new combination, and your chassis dyno guy wants you to just run a full pull, or your engine dyno guy wants to do a full pull and sweep it all the way across the full range first, that's just dumb. If you show up to the track with your brand new car, whether it's been dynoed or not, and you show up to the track and you make a full pull, that's just bad. You need to do short increments. So we're gonna do a short pull, just like you would make a short pass, like 100 foot. Come back, look at the data, make sure it's right. Then you make a longer pull, make sure it's right. And then you make a full longer pull and make sure it's right. Then you are ready to make a full pull, a full pass. So that's exactly what we're gonna do. I just, like I said, got it all started, running, idling, verified timing, made sure fuel pressure's right, because it's on methanol now, not on gasoline. So I already did that on gasoline yesterday. And so now I'm gonna make that short pull. All right, so right there you saw, that was the first attempt. That was wide open throttle. It wouldn't even rev up. So I come back, I look at the data, and I see what's going on. So that's, and even if it went perfectly well, which this next one probably after I figure out what was going on, it's even after that, I'm still gonna do a short little pull, come back, look at the data. So that's every time, that's what you always do. All right, so now I'd already done just the real short pull. This is the medium length pull where I only ran it up to just over 7,000 RPM. And I'll go in there and I'll show you the log real quick. But that's pretty reasonably good horsepower here. Let me get the cursor up on it. So that is 1,825 horsepower right there, and that's still climbing up here, so we're still going to be good. And currently this is on the low boost tune-up, so that's where we're trying to just sort everything all out at. So interestingly enough too, is that I built this engine a few years ago for a different customer. He traded this engine in for a SMX engine. I sold this engine to Dave Burns. Now Dave is saying, hey, I'm gonna get this thing all sorted out and I'm gonna trade this back in for an SMX engine. So it looks like this is the test mule for getting everybody's the baby engine, so to speak, of getting all sorted out. So that's just something interesting. But now that was our medium pull. Now I'm gonna go in, look at data. So remember, engine dyno or chassis dyno or at the track, even after you have dynoed, make a short hit, look at numbers. Make a bit longer hit, look at numbers. Make a longer hit yet, look at numbers, and then you can make a full pass. Never make a full pass on the first hit. It is a good way of having disaster. So let me put the camera down here real quick and I'll show you data log. All right, now you see that dark line right there, that was my short pull. This is my intermediate pull that we just did that 1825. Now this is a great example of why you have to do these things in order, because we didn't know it. This is why we test stuff. But engine RPM is great. It made a great pull. It made good horsepower. Everything looked fine. Even the O2s looked fine. But let me get rid of this stuff. It made 22 pounds of boost. So you can see right there, 22 pounds of boost. This thing normally goes, to 8,500 RPM. So that's why it's down on power, but it's because we're not revving it up all the way. And I don't rev it up all the way because of that. But if we look at our fuel pressure, I'm gonna get rid of all this other stuff here. Our fuel pressure is not boost referencing. As a matter of fact, it goes backwards. So you can see that blue line right there. This thing is losing fuel pressure. And if I would keep running this, if I just would have said, okay, let's just run this thing 8,500, it would have blissed flat out, run out of fuel pressure, and quite possibly, probably would have burned itself up. This is why you need to go through steps. Now, sometimes this will happen. It'll be fine on the hub dyno, and it's still bad in the car on the track. So that's why we still go through this on the track. Don't skip any processes. You need to sneak up on stuff and make sure all the numbers are right. So this thing, I'll jump out of the car here and show you what we just figured out, because we've been talking about it. And like I said, the car, this brand new car just got built, but obviously you can see that whole fuel pressure drops off right there. Really drops off, loses 20% of its fuel pressure, which is roughly 20% of fuel. So we're done dynoing because we can't fix this right now, because I'll show you what is going on. All right, out of the car here. So me and Dave are talking, and we're trying to figure out, because I know this thing has a large enough pump because I dynoed it on the engine dyno with this exact same pump, and I know how many gallon per minute pump this is. So this is like a 21 gallon per minute pump, which is way big enough pump. Turns out that fuel cell being up here in the front, for some reason, I don't know why, but I can't really see it. There you go. They used a -12 inlet line, and quite obviously, I would never run a -12 inlet line on a big methanol pump like this. Usually just will not work, and that does exactly what it does. The pump is way big enough. The motor is it's way bigger than what the engine is, what the requirement is, but if it can't suck fuel properly, it's not going to have fuel pressure. So potential crisis averted just by saying, hey, let's just always look at data in increments. But anyways, so we're done, because this all has to get torn apart and change the tank, change the line, change the fitting. So this is not a easy deal to just make happen today for Dave, but I can extrapolate out, and this is why we don't just tune exactly where the engine is running. I can extrapolate out up here There's the finger at, there we go. I can extrapolate out up there exactly how much fuel it's going to take and make this safe rich so that when we go to the track, he can sneak up on it at the track exactly the same way, making sure that it maintains fuel pressure, that it boosts references properly, and that this thing doesn't go lean and burn itself up. So that is it for today, because we are done. I think everything is really nice. It's almost exactly what it should be from right off the engine dyno. Everything's really good. We just ran into a simple thing of just a fuel line, an inlet fuel line being too small. So I am Steve Morris, Steve Morris Engines. Oh, if you guys want to see any more really good tech, I do have some. I don't have much on fuel pumps, oil pumps, but I do have a lot in my Steve Tech Whip videos if you go to playlist, and everything from rocker arms to camshaft design to piston design, blocks, sleeves, everything. So any of that kind of stuff you guys want to see more detailed videos of, go to my Steve Tech. I am Steve Morris. Have a great day.